right, we're going to be talking about molar mass. And these are the 3 steps to finding out the molar mass. Step 1 is last semester. You need to write the formula correctly. If you don't write the formula correctly, none of the other steps will matter. Step 2, once you've written the formula correctly, you multiply the number of the element by the mass. So if there's 2 hydrogens, I'm going to multiply by 2. The mass is on the periodic table. It's on the bottom, it has a decimal. And then step 3, we're going to add it all up. So here's an example.
Calcium phosphate. Before moving on, I want you to stop this and make sure you've written the formula correctly. So hopefully you wrote Ca3PO4 2, remembering that calcium is a 2-charge phosphate from the list, always checking, never guessing, is a 3 negative, and we crossed and dropped. That stuff's never going away, so if you didn't learn it last semester, go ahead and learn it today.
Alright, so here's our step 2, where we multiply. So looking at the formula, there are 3 calciums. So multiply 3 by the mass of calcium, so you need to look on your periodic table. The number for calcium on the very bottom, 40.078. I have 3 of them, so it's 3 times that. So I got 120.234. Same thing for phosphorus. Don't forget, this is just like math. You distribute that 2 to everything. So there's 2 phosphoruses, and each one of them is 30.9738, so we multiply it by 2. Same thing for the oxygen. That 2 is distributed, so there are 8 total oxygens. So it's 8 times 15.9994.
And the last step is to add them up. And you get the mass 310.1768 grams for calcium phosphate. When you're doing your molar masses, you want to go ahead and use all the decimals that are there. When you give us our final answer, we'll talk about how many we want in the final answer itself later on in the unit. So how are we going to use our molar masses? Well, we're going to use it for conversions. So the first thing to know is the mole. The 1 mole is equal to the molar mass. So everyone in the past has always wanted a formula, so I've given you a formula here. Your N stands for moles. The little m is your mass of how much you have, and the big M is molar mass. So hopefully you've done things like this before. So if you're looking for your N, if you're looking for your moles, you take your mass and divide it by your molar mass. If you're looking for your mass, then you take your moles and multiply by your molar mass. And we can do the same thing with how many pieces we have, where 1 mole is equal to 6.02 times 10 to the 23rd pieces of whatever pieces we're talking about. It doesn't matter. It's like a dozen. A dozen apples is 12. A dozen oranges is 12. A mole of calcium is 6.02 times 10 to the 23rd atoms. A mole of sodium is 6.02 times 10 to the 23rd. A mole of pebbles is 6.02 times 10 to the 23rd. It's always the same. And it's similar to the previous triangle. Your N is your moles. The number sign is how many. And this A is Avogadro's number, which is that number right there. So if you're looking for how many you have, you'll multiply your moles times Avogadro. If you're looking for how many moles you have, you take how many you had and divide it by Avogadro's number. So we're just multiplying and dividing in this unit. So let's try a practice problem.
Alright, example number 1. If you have 10 grams of sodium hydroxide, how many moles do you have?
Well, the first thing you have to do is write the formula correct. Ta-da! And then we have to find our molar mass. And so we look those up. Sodium is 22.9897. Oxygen is 15.9994. And hydrogen is 1.00794. and you're going to get approximately 40 grams. So because we are looking for how many moles, we want to know our moles here. This is what we're looking for. You're going to take your mass and divide it by your molar mass, which should be the next slide. So 10 divided by 40 is 0.25. So let's try going in the opposite direction. So here's another example.
If you have 0.5 moles of carbon dioxide, how many grams do you have? Same thing, you need to start with a formula. CO2, hopefully that's what you got. Now we need to find the molar mass of carbon dioxide. So we need to add them up.
Carbon is 12.011, and oxygen, you got two of them, so you're multiplying that by 15.9994. And I hate to break it to you, there's going to be about 5 elements that you're going to know without having to look at the periodic table. So if we're looking for grams, this is our unknown now. You'll take your moles times your molar mass, and I believe the molar mass is 44. It's about 44, we'll see. Yep. So 0.5 times your 44 equals 22 grams. So we've done from grams to moles and moles to grams. So now we're going to work with how many we have.
Alright, so this time we have 0.25 moles of rubidium nitrate, and we want to find how many formula units do you have. So we're looking for how many formula units. So same thing, we still have to write the formula correctly.
Okay. Before we move on, remember that we're going from moles to how many. So what do you think we're going to do here? We'll take our moles and multiply it by Avogadro's number. This is actually, even though you want to be in the habit of writing your formulas correctly, when we're dealing with how many, it doesn't really matter what the formula is. It just matters what are you going to do with the calculations. So rubidium nitrate is RbNO3. You had 0.25 moles. We multiplied it by Avogadro's number, and we found out that we had 1.51 times 10 to the 23rd formula units. That's a very big number. That's why we use scientific notation. Now, when we're kind of a sidebar, formula units is when we have ionic compounds. If we're talking about molecules, it's covalent. It's still the same thing. It's how many do you have. So that'll sometimes throw people off. So your covalent is molecules, ionic compounds are formula units. Last example.
Alright, so this time we have 4.03 times 10 to the 24 molecules of sulfur dioxide. So we know how many we have, and we want to know how many moles we have, so we're looking for N.
So to find our N, you're going to take how many you have and divide it by Avogadro's number. And you find out that it's 6.69 moles. Now, if you have any questions on any of this, obviously you can ask us in the class. All you have to do is bring us your notes and ask the question, and we'll clarify. We'll do some practice problems on all of this in class next time, which is why you need to do this for homework. See y'all in class.